So this is the 2004 free-response question. Question number 1, there was no drawing, just a question. Let R be the region closed by y equals square root of x minus 1. Call f of x. The vertical line, x equals 10. Somewhere out here there's 10. And then the horizontal line, the x-axis, y equals 0 right here. So we're trying to find the region. They called it R right there. And this is a calculator portion. It says find the region R. So what they did, they said, hey, area is just the curve. You can see it here. I don't really need to rewrite it. From the integrants 1 to 10, the function dx. The limits is at 1 to 10 we're worth a point. The integrant itself, square root of x minus 1 dx is worth a point, and the answer 18 is worth a point. Pretty simple problem, all right? Pretty quick. The next one is find the volume of the solid generator when R is revolved around the line y equals 3. Now, the hard part here, all right, if you plug in 10, all right, you have to capture, it helps you see that this is the line y equals 3. Okay, and it hits at this point, right? Because at 10, that ordered pair, when you plug in 10, is 10 comma 3. All right, you're going to revolve that around this line, all right? So again, I think this creates a wash, RO and RI. And again, they go right to the answer. That's what they're looking for. But I would start with volume equals, and since it's pretty obvious, 1 to 10, AX dx, all right? And then you say, well, what kind of shape do I have? Well, I have a washer, RI and RO. Well, again, RO is really easy this time. You guys agree? RO is the x-axis. RO is always 3. RI, and again, we get used to this, is 3 minus f of x, or 3 minus the square root of x minus 1. Think of that as one thing. Again, we know from washers, we probably can start. I don't skip this step personally. I write it out every single time so I don't make a mistake. So I get this. I put the pi here, 1 to 10. RO this time is 3 squared minus the 3 minus the square root of x minus 1 squared dx. And you notice the only difference between my answer and what the AP test has is they made 3 squared into 9 here. All right, they left this as this ugly two-term thing squared. You put in your calculator, and it should have given you one of these two answers. And again, this is back in the days when they had 3 decimal points. We go 4. You notice it's 0.057 or 0.058. We now go 4 decimal places. Limit and constant. Pi and 1 to 10 with a point. Okay, there's one of them. The integrant. They would give you a point for mine too. Okay, mine would give you 0.2. 3 squared is 9. All right, and the answer 212.057 or 212.058. And again, the TI calculator would do that, and I'd write that note. Here's where we stand. Okay. Now, the next one says find the volume of the solid generated when R is revolved about the line x equals 10. I'm going to go to the next page because that's where I have the answer. And we had a lot of struggles with this. And again, this is a practice issue. All right. You know that the graph goes from 1 to 10. And here's R. But we're going to revolve it instead of around the x-axis. We're going to revolve it around the line x equals 10. All right. We're going to revolve around this line. And they want to find the volume again. Well, volume, there's 2 ways to do volume. We either can do, cylindrical shells, or we can do around the y-axis. Guys, this is the case of, I'm going to do, it's the integral from A to B of AY dy, because it's about a vertical line, right? So it has to be about the y-axis. And this is the line square root of x minus 1. Well, first of all, I have to solve that for x. I get y squared equals x minus 1. I get this line right here is going to be y squared plus 1. Right? And I'm going to revolve that about the line x equals 10. All right? Again, we have to see that we are taking a region, all right, and coming around. So again, we got RO and an RI. This is a washer, guys, all right? So and that's what I think a lot of you guys miss, because you can tell, or it's not a washer, what am I saying? It's a ring. I mean, it's a disc. I said washer. It's a disc, right? You guys agree this is the radius? There's no gap, right? And we know this point is 10, 3. We know this point is 0, 10. So the limits of integration this time are 0 to 3 on the y-axis, right? And I just have a solid ring, which I'll call for a radius r. So you guys agree that's pi r squared dy.
Don't you have the first word here wrong?
Huh?
Shouldn't that be 10, 0?
Oh, yes, I do. 10, 0. Yes, thank you. Yes. But the point is, yes, I wrote it wrong on the board. The point is that it goes from 0 to 3. Thank you for catching that. Now, it's pi r squared, okay? But what is this length r? All right. Well, to me, r here is the distance 10. The whole distance here is 10. You guys agree? Back to this axis, minus what I'll call some x value, right? But x this time is equivalent to y squared plus 1. Can I go through that again? You start from 10, and you want to go to this point on the curve. Well, you go this far, we want this point, and it changes as you go up. Well, this is always 10. This is always x. So the distance in green is always 10 minus x. We know x is equivalent from solving for x to y squared plus 1. That becomes your radius. And when you look at what was scored, and I put that in, I bring the pi out, 0 to 3, and that is a point. Pi from 0 to 3 was a point. 10 minus y squared plus 1 squared dy. All right? And when you look at what they scored, that's exactly what they have. And again, that's the integrant, and then use your calculator to find the value, which came out to be 407.15. All right? The best thing to do is take some notes like you guys are doing, let this sit, try these again. These are a lot like our textbook, Stewart's textbook, when we were doing all the revolving, which is what, 6.3 and 6.4 in the textbook. You want to take a look at those.